Forward. Ooh-wee. So today's May. It's May. It's May. Is it May Day? Is that what they call that? May Day? The 1st of May? Is that a thing? Oh, I'm gonna call it May Day. 5/1/20. What is this year? Is this 2023? All right, good. So I just thought maybe I went in a time machine or something. So this is the practice quiz. You should be humming through these problems relatively quickly. First one is x squared minus x minus 30. You don't have to move anything. It's just ready to go. The factors that you found should have started like this. You should have placed x's. Because of the minus on the 30, you should definitely have one of each, one plus and one minus, one positive, one negative, call them whatever you want, but there's one of each. And the numbers that you want are positive 5 and negative 6, which those, remember, are not the answers. Those are the factors. And so the answers that we get are the numbers that make the factors equal 0. The first one presents a negative 5, and the second one presents a positive 6. And that is that. All right. Second problem, again, is already set equal to 0. So I was just trying to give you a couple where you didn't have to worry about the annoying stuff at the beginning. So this one, I hope it's obvious, has to factor like this. That's the only way to make 3x squared. And again, there's a negative on the 4 in the back, which tells us that there has to be one of each. And I'll just place them knowing full well that I might have to switch them. But the clue here is the 11. The 11 in the middle that I'm trying to make tells me that I should definitely put a 4 polar across from the 3, because that's going to get me 12, which is really close to 11. And as you see, my signs are backwards because the 2 in the middle make 1x and the 2 outside make minus 12. And that's not the correct like power balance. So what I actually want is for it to come out to plus 11. So I want to put the plus on the more powerful product and put the minus on the wimpier one. And again, the answers are what make the factors equal 0. So this one gives us 1 divided by 3. And then this one gives us just regular old negative 4. So those are my solutions for the second one. And I'm recording this, so if you want to go back and watch this later, you're welcome to. I'll post it, of course, on Canvas. So we have the third one is 2x squared minus 7x minus 30. Remember, you got to get it set equal to 0. That's what makes all this work, of course. I know this one factors into 2x and 1x. And I'm sorry to be a broken record, but again, and I didn't mean for this to happen, but I just kept putting negatives in the back, just happened. So again, the negative on the 30 tells me that there has to be one of each, and it does turn out to be a 6 over here and a 5 over here. And I know that that's the correct balance because the 2 in the middle make 5x and the 2 on the outside make minus 12. And that comes out when you add them to 5 minus 12 makes negative 7, which is exactly what we wanted. So again, the answers are the things that make the factors equal 0. For the first one, it's negative 5 divided by 2. And then the next one is just regular old positive 6. No need to divide by anything. And then, of course, the last one is, again, it takes some manipulation. So you want the 6x squared in front. You're going to pull that 13x across and make him plus. And then you're going to pull the 28 across and make him minus. And this was intended to be the one that would present the most challenge for you. I'm telling you where I always start is, this is what makes this a hard problem, is the fact that there's multiple potential templates. So there could be the 6x times x template. I always start, I'm not making any claims that that means it always works. I'm just telling you I find more success if I start with the pairing off that's not just the whole number times 1. If it was like a 9, I would start with 3 and 3. If it was a 12, I'd start with 4 and 3. Like, I'm always going to start there. That's what I do. It seems to help. And again, look at that. There's a minus on the 28, so I know that there's got to be one of each. So I'm just going to slap a plus in one and a minus in the other. If I have to switch them, I'm not going to cry about it. I'm going to turn my pencil over and switch it. I don't care. And it turns out that I want a 4 and a 7, and that's going to give me 8 and minus 21, which the balance of power is off, because 8 and minus 21 make negative 13, but that's okay. So that just means, again, that I have to take my plus minus and switch it to minus plus. And that works now because it's negative 8 plus 21, which is, of course, 13. So the answers are x equals 4 divided by 3 and x equals negative 7 divided by 2. So that's what I expect you to be able to do as far as factoring is concerned. Should be a relatively quick process. Just build your shells, build your front parts, look at the number in back, determine your signs, and then just go click, 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 click. As far as the quadratic formula is concerned, on the first problem, I see an a value of 2. I see a b value of 10, and I see a c value of negative 11. So my first step said x equals, here it goes, the opposite of b plus or minus the square root of b squared minus 4 blank blank. And then I divide it all by 2 times a, and 2 times 2 is, of course, 4. Then I go back and I fill in a and c. So in place of a, I put 2, and in place of c, I put negative 11. I can see that this minus that I'm pointing to with a yellow arrow is going to change to addition because he encounters a negative down the line. And so it really winds up being 100 plus 88. That's what that is. So my next line would say x equals negative 10 plus or minus the square root of 100 plus 88, which is, of course, 188. And then, as always is the case, it's our job to consider the radical. That's always where we are at this point in the process, is to say, well, what can I do with u? And the best you can do with the square root of 188 is break it down. And this is, what calculators are for, is to help us with this kind of stuff. But it does break into 4 times 47. That's 160 plus 28. So yeah, 188. And so what I'm going to do is I'm going to replace this square root of 188 with something better. I'm going to say x equals negative 10 plus or minus 2 root 47 all over 4. And then the final step in this process is to do the triangular division, the Dorito, call it whatever you want. But there are 3 free numbers now out and about, and they all can be divided by 2. And so when I do that, I get my final answer, which is x equals negative 5 plus or minus a 1 that I don't need times the square root of 47, and then a 4 divided by 2 is 2.
When I cross that,
You're good? You're good? Okay. The second quadratic formula problem is, again, no need to move anything. So the a value is 5, the b value is 3, and the c value is negative 92. And so the first step is just like autopilot. X equals the opposite of b plus or minus the square root of b squared minus 4 blank blank, all divided by 2 times a, which is 2 times 5, which is 10. And then I'm going to go backfill. A becomes 5, C becomes negative 92. And yet again, I see, I'm going to point to it again, your consideration at this point, if you want to be any good at this, your consideration now has to be looking at the sign with the yellow arrow. Does he stay minus or does he switch to plus? He switches to plus. So really what's happening inside the square root sign there is a really big addition problem. It's 9 plus 4 times 5 times 92, which your calculator, again, exists for things just like this, for moments just like this. So it comes out to negative 3 plus or minus the square root of 1,849. And if you've been in class and you've been listening, you're not scared of that, because you know that before you try to make a tree, and a tree on a number that big is scary, that's daunting. But the first thing you want to do is just type it in your calculator and say, hey, maybe I can just square root it. And of course you can, right? And so it winds up, this just equals regular old 43. So I'm going to swap out the square root of 1849 and change it into what it actually equals, which is 43. Just regular old 43. This becomes now a pathway problem. These numbers are what we call rational. So I'm going to trace the top pathway. Negative 3 plus 43 is 40. and I divide it by 10. So one of my answers is 40 divided by 10, which is 4. The other pathway is the minus, and -3 minus 43 is -46, which if I divide it by 10, I don't really divide it so much as I just reduce it. It comes out to x equals, bless you, -23 over 5. So those are your answers for problem, I guess that would be problem number 6 if they were numbered, but that's that. All right. Third one, you got to do some moving things around. So you want to leave the 6x squared and you want to leave the plus 5x, but you do want to pull the 25, thereby making him minus. So the numbers that we're going to use for the formula are 6, 5, and -25. And as always, here we go. So x equals the opposite of b plus or minus the square root of b squared minus 4 blank blank all over double A, and double 6 is, of course, 12. Backfill, A becomes 6, C becomes -25. And again, for the third straight time, this minus will switch to plus. So what winds up happening here is you just wind up with 25 plus 600. And you don't want to forget to add the 25, right? Yeah. So it winds up inside there becoming 625. So we now have x equals -5 plus or minus the square root of 625. And I get it, like it's instinctive to now go off to the side and start making a tree, but for the 934th time, it's not necessarily necessary. Not necessarily necessary. Interesting. Just check it. You're like, oh, nice. I can just square root you. The square root of 625 is just 25. How lovely that that could possibly happen. So if I just swap it out, I'm back just like I was on the problem before with my two pathways. So one of the pathways I shall call him plus. -5 plus 25 is 20. So 20 over 12, which reduces to, divide them both by 4, you get 5/3. The other pathway is the minus, and -5 minus 25 is -30. So I put -30 over 12, and I divide those both by 6 because I can, and I wind up with -5/2. So those are your answers for that one. All right. Which leads us then to the last problem. And the last problem, it just, again, requires some setup. I don't like my x squared to be negative under any circumstances. So the quadratic formula can handle it, but it really makes things trickier as far as where interpreting where negatives go. And so my advice to you is just always make him positive. Just do whatever you have to do. Make x squared positive. So in this case, I'm going to pull my x squared across to the left and say, all right, you're positive now. And everyone else, you come along for the ride. The 12x was already there, so he stays positive. And the 13 does have to move, so he also becomes positive. And now I've got my A is 1, my B is 12, and my C is 13, and we're off to the races. So x equals the opposite of B, plus or minus the square root of b squared, which is 144, minus 4 blank blank, all divided by double A. 2 times 1 is 2. Go backfill your A and C values with a 1 and a 13. And for the first time, I point to that minus sign and say, it doesn't switch. It stays as a subtraction problem. So what's really happening inside the root sign now is 144 minus 52. Because that's 4 times 1 is 4 times 13 is 52. So you wind up in there with 92. So our next line should say x equals -12 plus or minus the square root of 92. And this time you do have to go off now and make a tree. So when I go and I break down the square root of 92 and I go branch, branch, root, root, 4 and 23 make 92. So that becomes 2 root 23. So I'm going to swap that out. So I'm going to take 2 root 23 and put it in there. And then yet again, there's a triangle And I'm going to divide those numbers all by 2. And I'm going to wind up with an answer that says x equals -6 plus or minus. And I do get 1s on both of these. And I don't need either of them. Those are the places where 1s don't need to be. So it's just -6 plus or minus √23. And that is that.